Hey, fifth grade, welcome to your rock cycle lecture. Go ahead and get the slides pulled up if you haven't already. Pause the video if you need to. It is chapter 9, pages 102 to 105 in your book, so you can follow along on that as well. So the first thing we're going to talk about are minerals. You know what minerals are. A reminder of its definition. They're solid, inorganic, naturally occurring substances found on Earth with crystal structures, or crystalline structures, meaning it's a bunch of little crystals, they're solid, and they look really pretty. A lot of minerals you already know, you just didn't know them. Um, they're usually used in things like jewelry, rubies, emeralds, sapphires, diamond earrings, all that kind of stuff. Um, Even minerals are used to flavor foods like salts. The salt you have on your dinner table every night is called halite or halite, and it's really sodium chloride, but in its mineral form, that's what it is. Also using tools, graphite. You use this every single day when you write with a pencil. Um, if you've ever heard of talcum powder, baby powder, talc, it's a mineral, and many, many, many other things. We use minerals for everything. What minerals do are they combine different ways to make different kinds of rocks. About 20 of the most common um, minerals make up all the kinds of rocks we have on Earth. There are over 3,000 minerals, but about 20 of the most common are like what you would find outside, or in a volcano, or on a cliffside, all around the world. Some of the examples there that you see on the screen, the first one on the left is something we talked about before, fool's gold. It's pyrite. The one in the middle is a gypsum. And the one on the right, the purple pretty one, is amethyst. Those are all examples of minerals. There's lots and lots out there. Anybody has a rock collection, have minerals in there. So the next slide, slide 3, is the rock cycle. So the rock cycle describes the geologic changes over time through 3 main types of rocks. Okay, and they're kind of weird words. Igneous, sedimentary, and metamorphic. Those are the 3 main kinds of rocks, all made up of different kinds of minerals. They all look different, they all act differently, and the changes between these types of rocks occur when rocks are buried inside the earth and experience heat and pressure. Okay? So, the first one we're going to talk about are the igneous rocks. And igneous rocks form when lava hardens. Remember, lava is the magma that reaches the surface. So when a volcano erupts, what's inside it in the base of the volcano is called magma. That's all the hot, hot, hot red stuff. And when it erupts, everything that comes out, the second it hits the surface of the earth, it's called lava. And lava cools, and it can form 2 kinds of igneous rock. The first one's intrusive, meaning it cools very slowly and makes very large crystals, or extrusive, which cools quickly and has smaller crystals. Okay? Examples of igneous rock are on slide 5. Granite and basalt. Granite you see probably all around if you have granite countertops maybe, or you've been to like a Home Depot where they have granite countertops. It's all made of that kind of rock. They just put it all together, smooth it out, sand it down, gloss it, and it makes a pretty countertop. Basalt is used for lots of different things, building materials as well. Slide 6 is all about sedimentary rock. Sedimentary rock forms when small pieces of other rocks, minerals, plants, animals, whatever, are deposited in layers. You've probably heard of sedimentary rock if you've ever studied fossils. The sedimentary rock is a result of weathering and erosion. So imagine we have a whole group of rocks over here on this cliffside. Eventually, they're going to get worn down by wind, water, whatever, and it's going to break down into particulates. And all those particulates will go somewhere. They're usually deposited underwater. And over time, all these particles get compacted and they cement together and they're pressed together over time and they form a whole rock. If you ever picked up a rock and you've seen like stripes on it, they're called bands. That's a sedimentary rock. Everything's been squished together in these layers, and That makes it a sedimentary rock. And a fun fact, that sedimentary rock is the only form of rock that holds fossils of dinosaurs and stuff. Because remember when the dinosaurs died out, they all, fell into the ground or fell into the water, and over time, all the dirt and the rocks and everything that broke down landed on top of them. And years and years and years of all these rocks breaking down, their particles layering on top of the dinosaur and then all these other layers of rock, it cements down, forms a rock, sedimentary rock, and that's where the fossil is, so you can find your little T-Rex friend. Well, not quite so little, but. So examples of sedimentary rock, you can see a sandstone where you can see the banding there, and then a limestone where it's just another example. You can't see the banding here, but it's still a sedimentary rock. It was formed the same way. And limestone's used a lot in building as well. Our last kind of rock is a metamorphic rock. And you can tell by the name that if you've ever heard of metamorphosis, which you probably have with butterflies, it means it's changed. So this is when a large amount of heat or pressure changes any other kind of rock, whether it be sedimentary or igneous, okay? The amount of heat and pressure it undergoes depends on the type of metamorphic rock it makes. So if I have a piece of granite that's way underground usually, because that's where there's lots of heat and pressure near the core of the earth, it's going to undergo a lot of pressure, and it's going to undergo a lot of heat, and it'll eventually turn into something else. Okay? So examples of metamorphic rock are marble, which you've seen probably in like a tile floor or maybe a sink, all that kind of stuff used for building. And something that's called gneiss. I know it's spelled really weird, but it's nice, like I'm being nice to you. That's another example. You can see that it has the bands in it. So this tells you it was a sedimentary rock because it has all the layers, but then it underwent a bunch of pressure and heat, and now it is a metamorphic rock. The last thing we're going to talk about is why the rock cycle is so important. Miss B, why do I care about how rocks form other than the fact that it's science class? Well, this tells us how we can predict that how rocks will change. So via the rock cycle, we know that igneous rock is formed when other types of rocks melt, then cool, then harden. Sedimentary rocks formed when wind or water erode something and then they layer together. And then metamorphic rock is when it undergoes a lot of heat or pressure. So if we have a metamorphic rock, for example, the little note there, it tells you if it keeps undergoing more heat or pressure, it's always going to be a metamorphic rock until something new happens to it, like erosion or melting. If we have a rock that's near a volcano, maybe it'll melt, because maybe it'll end up in the magma. So that might melt and harden and become an igneous rock. So the rock cycle is a prediction tool to see what's going to happen to the rocks all around our world. And that's important because, hey, you might need a new resource, or hey, the rocks in this area may shift and we need to deal with that. Okay? So that's your rock cycle lecture. No homework for today. Yay. You do have a rock cycle assignment that is tomorrow, so make sure you do that.